My name is Ismail Ismailzadeh and my major is computer science.
Hello, my name is Ilham Jalilov and I am a computer engineering student.
Hello, my name is Ali Aliyev and I'm major in computer science.
My name is Jawah Ahmad. My major is computer engineering.
First of all, we place two push buttons that will serve as the inputs of the AND gate. Each button represents one input, A and B. The right sides of the buttons are connected to the positive rail, while their left sides are connected through the resistors to the base of the transistor. These resistors are used to limit the current going into the transistor and protect it from the damage. Next, we connect the emitter of the transistor to the negative rail. The collector of the transistor is connected to one of the legs of an LED, which will act as an output indicator. The other leg of LED is connected to the positive rail through another resistor to limit current. In this setup, the LED only lights up when both buttons are pressed at the same time, meaning both inputs A and B are high. If either one or both of the buttons is not pressed, the transistor won't conduct and LED will stay off. Therefore, the circuit demonstrates the behavior of AND gate. The output is on only when both inputs are on.
We built an OR gate on the breadboard using transistors, resistors, jumper wires, push buttons, and an LED. First, we placed two small push buttons. From one side of each button, we connected a jumper wire to the positive rail. Then, from the other side of each button, we connected a resistor to the base leg of each transistor. We used 4 resistors in total and one of them had a different resistance value to control the current going to the LED properly. Next, we connected the emitter legs of both transistors to the negative rail with jumper wires. We joined the collector legs of the two transistors together and connected them through another resistor to the base of a third transistor, which works as the output stage. The emitter of the third transistor was connected to the negative rail, and its collector was connected to one side of the LED lamp. The other side of the LED was connected to the positive rail through another resistor. When we powered the circuit, pressing either one of the buttons allowed current to pass through one transistor, which activated the third transistor and turned the LED on. If both buttons were pressed, the LED stayed on as well. When neither button was pressed, no current reached the base of the output transistor, so the LED stayed off. This behavior shows the logic of an OR gate. The output is on when any of the inputs is on.
To create our NOT gate, we started by connecting the two sides of the breadboard with wires just to make future connections easier. Then we placed a button, one leg connected to the positive rail and the other to a resistor leading to the base of a single transistor. The transistor's emitter was connected to the negative rail. Next, we added an LED as the output. Its shorter leg was connected to the negative rail and the longer leg, the anode, was linked to the transistor's collector using wires. We also included a resistor from the power supply to protect the circuit. At one point, we accidentally swapped the stronger and weaker resistors, which stopped our gate from working, but after fixing that, everything worked perfectly. And with that, our NOT gate was complete and ready to demonstrate.